graphing systems of linear inequalities. Systems implying more than one, right? So, let's just start with this first one. And it is already in slope-intercept form for me, which is so nice. So let's just use the y-intercept of +2. And then what's my slope? So down 1 over 1, right? Down 1 over 1. Now, as I'm about to graph this line, what should I make sure I do so I don't have to worry about not being able to erase my marker?
Dotted.
It is definitely a dotted line. Why? Not or equal to. Love it. All right. Now the next thing I need to know is which way should I shade? It says it is less than. So I can do a test point, or I can look at my y-intercept and I can say less than. So you were correct. I'm just going to do this lightly, you guys. Lightly, lightly, lightly. You don't remember why, you'll remember why in a moment. So we have two equations, and we're going to graph them both on the same coordinate plane. So let's look at our next one. What's our y-intercept? +3. So we're going to go up 3. What's my slope? Up 2 over 1. Solid or dashed? All right. And am I going slow enough? Yes. Which way would I shade? This one also says less than. So less than that y-intercept would be this way, right? Now, lightly, 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 because what am I really looking for?
Where they intersect.
I'm looking for where they intersect. Absolutely. Where they intersect is my solution. That area right there is what makes both inequalities true. Now, Alex has a nifty, you'll shade, and then you can go back and you can erase the sections that you don't want. So no, that will come into play. Let's do one more. Would you guys like to do the intercept method or slope-intercept form? I am taking suggestions.
How do you even get the slope-intercept?
We would need to get the y alone. We'd need to move the x over and then divide. Would get a slope-intercept form. The intercept method is letting x equal 0 and then y equals 0. Slope-intercept form? Okay. That's all right. Here we go. Sam asked, and we said move the x. So I'm going to take away the 3x and put it on the other side. And then, what do we need to divide by? All right. What are we dividing by? By a negative, so I have to flip my sign. Don't miss it because you forgot to flip your sign. Okay. My y-intercept here then is -1/4. If that were an Alex problem, you'd have to plot that point, right? What's my slope? Up 3 over 4. 1, 2, 3. 1, 2, 3, 4. Solid or dashed? Dashed. It's not or equal to. And do we shade above the y-intercept or below the y-intercept?
Above.
Above, because it's greater than. Perfect. Lightly, lightly, lightly. Next one. Let's move that x over to the other side. Greater than or equal negative x plus 7. And divide everything by 2. Any reason to flip my inequality this time? Nope. Leave it the same because we are not dividing by a negative. It's a positive 2. So negative 1/2 x plus, if you don't like to graph 7/2, could you call that 3.5 if you wanted to? Yeah. All right, so my y-intercept is at 1, 2, 3 and a half. My rise over run from there is, how many people like to go up and left? I'm curious. Up and left. How many people like to go down and right? Is it the same thing? All right, just curious. So let's see, down 1 over 2? Down 1 over 2. Solid or dashed? Solid. And which way do we shade? It says greater than. So look at your intercept. Greater than that intercept would be up the y-axis. Where do these intersect? Right here. That is our true solution. What's that? Oh, shoot. I can give you a blank one over there. Did I mess up?
Dave, will you please excuse Sophie Stewart?
I will.
Thank you.
Right here? The greater than one? So from my y-intercept, greater than would be up the y-axis, yes? Are we okay? I could have made a mistake, that's why I'm double checking. We all right? Okay. Last one, nothing to solve here, but what would a no solution look like if you were to graph it? Parallel lines and what?
Outside.
Shaded outside. Perfect, shaded outside. So we would have parallel lines, pretend those are parallel, and those would be shaded where they would never intersect. I believe you will zip through today's homework. There are a couple 3-line problems that will be in there to surprise you, but you can handle it.